Hello and welcome to a journey into the strangest and most mysterious branch of science, quantum mechanics. Imagine a world where particles can be in two places at once, where observation changes reality, and where two objects can be connected across vast distances, instantly affecting each other. This is not science fiction, this is quantum physics, the foundation of modern science that has given us everything from semiconductors to quantum computers. But at its core, quantum mechanics challenges everything we thought we knew about reality. So, buckle up, because today, we're diving into the bizarre, mind-bending world of quantum physics. 1. What is quantum theory? Quantum theory is the branch of physics that describes the behavior of atoms and subatomic particles. Unlike classical physics, which governs the macroscopic world, quantum mechanics tells us that at the smallest scales, reality is uncertain, probabilistic, and often paradoxical. At the heart of quantum mechanics lies a fundamental idea: nature is not deterministic. In other words, instead of knowing exactly where a particle is or what it's doing, we can only assign probabilities to its possible states. One of the key principles that demonstrate this uncertainty is called the Heisenberg uncertainty principle, which states that we can never know both the exact position and momentum of a particle at the same time. This means that at a fundamental level, the universe is unpredictable. But if quantum mechanics is so strange, how do we know it's real? 2. The double-slit experiment, the mystery of wave-particle duality. One of the most famous and shocking experiments in quantum physics is the double-slit experiment. The classical expectation. Imagine we have a wall with two narrow slits. If we shoot small particles, like marbles, at the wall, they should pass through one slit or the other and form two bands on a detector screen behind the wall. That's classical physics, it's predictable. What happens with light and electrons? However, when scientists performed this experiment with electrons or photons, something incredible happened. Instead of forming two bands, the particles created an interference pattern, as if they were behaving like waves and not individual particles. But here's the strange part. When scientists placed a detector to observe which slit the electron passed through, the interference pattern disappeared. Suddenly, the electrons acted like particles again, forming only two bands. This means that the mere act of observing the experiment changed its outcome. But how? Does reality exist only when we measure it? This question leads us to one of the most profound mysteries in physics: does observation create reality? 3. Quantum superposition, Schrödinger's cat. Quantum mechanics introduces a concept called superposition, which states that a particle can exist in multiple states at the same time, until it is observed. To explain this, Austrian physicist Erwin Schrödinger proposed a famous thought experiment. Schrödinger's cat. Imagine you have a cat inside a box, along with a radioactive atom and a vial of poison. If the atom decays, the poison is released, and the cat dies. If it doesn't decay, the cat remains alive. But according to quantum mechanics, until we open the box and observe the cat, it exists in both states simultaneously, it is both dead and alive at the same time. Only when we look inside does the cat choose a state. This is a mind-blowing concept because it suggests that reality doesn't exist in a definite form until it is observed. 4. Quantum entanglement, Einstein's spooky action at a distance. Another mind-boggling phenomenon in quantum mechanics is quantum entanglement. When two particles become entangled, their states become linked, no matter how far apart they are. If we measure one particle, the other state changes instantly, even if they are light-years apart. Einstein famously called this spooky action at a distance, because it seemed to violate the speed of light limit. But quantum mechanics predicts it, and experiments have confirmed it time and time again. This has huge implications for the future of quantum computing and quantum communication, as it could lead to unbreakable encryption and even instant data transmission across vast distances. 5. Quantum computing, the future of technology. Speaking of quantum computers, how do they work? Unlike traditional computers, which use bits, zeros and ones, quantum computers use qubits, which can be in a superposition of both 0 and 1 at the same time. This allows quantum computers to perform calculations exponentially faster than classical computers. Some potential applications include revolutionizing artificial intelligence, solving complex problems in seconds, breaking traditional encryption methods, designing new drugs and materials. Companies like Google, IBM, and Microsoft are racing to build the first practical quantum computer, and when they succeed, it will change everything. 6. The many worlds interpretation, is there more than one reality? One of the most fascinating interpretations of quantum mechanics is the many worlds interpretation, MWI. This theory suggests that every quantum event creates a new parallel universe. For example, if Schrödinger's cat is both dead and alive, there are actually two separate realities, one where the cat is dead and one where it is alive. This means that there could be an infinite number of universes, where every possible outcome of every event is played out. Could this explain déjà vu? Alternate realities? The multiverse? Scientists don't know for sure, but if true, it would mean that every choice you make is leading to a new branch of reality. Conclusion: the future of quantum physics. Quantum mechanics is not just a theory, it is the foundation of modern technology. From lasers and transistors to quantum computing and cryptography, its impact is everywhere. But the strangest thing about quantum physics is that it forces us to question reality itself. Does observation create reality? Do parallel universes exist? Is the universe fundamentally random? These questions remain unanswered, but one thing is certain: the quantum world is stranger than we ever imagined. If you enjoyed this video and want to explore more mind-blowing scientific topics, don't forget to like, subscribe, and hit the notification bell. What do you think? Could quantum physics hold the key to understanding the universe? Let me know in the comments. See you in the next video.